Hi, welcome to another video of the Alarm series. In this video, we are going to explore the alarm system view called Power Quality Incidents, its configuration, and how to navigate through the alarms that are displayed there. Let's begin. One of the best ways to understand the alarm system views is by examining their configurations. To see how this view is configured, click on the three dots and select Edit. As you can see, this view is set to public, meaning any user can access it. The view type is Alarm History with a detail level of incidents. In terms of priority, high, medium, and low are enabled, excluding the raw events indicated by the gray rectangle. Regarding state, it is configured to show active or unacknowledged incidents. With no filter for sources, meaning all devices in the system are included. The key part is in categories. You will notice that only power quality is enabled, while the other four categories are disabled. Click on the ellipsis next to power quality to see exactly what types of alarms are included in this category. There are 11 power quality alarm types: flicker, harmonics, overvoltage, swell, unbalance, undervoltage, frequency variation, interruption, sag, transient, and unclassified disturbance. This means that in this system view, you will only see these types of alarms and no others. There are additional filters like voltage tolerance, disturbance direction, and load impact, but I'm showing you all of them are not enabled. Nothing configured here. Nor here. Nor here. Let's stop for a moment to recall on each of the power quality types that are available. A flicker disturbance is a repetitive low-frequency modulation of system voltage. These disturbances are usually caused by a large fluctuating load somewhere within the power system. It can happen because of things like big machines turning on and off or changes in the electricity supply. Lighting systems typically flicker when such disturbances occur. Harmonics. Harmonics refer to the distortion of the normal sinusoidal waveform of the electrical current or voltage. Harmonics in electrical systems are primarily caused by nonlinear loads, devices that draw current in abrupt pulses rather than smooth sine waves. These pulses distort the current waveform, introducing harmonics. To explain the next two alarm types, picture the ideal voltage waveform with its nominal voltage. If this voltage goes over 110% of the nominal voltage, and depending for how long this happens, the power quality event is called overvoltage or swell. If this behavior lasts between half cycle and 1 minute is called swell. If it lasts longer than 1 minute is called overvoltage. Now if the voltage drops under 90% of the nominal voltage, and again depending for how long this happens, the power quality event is called undervoltage or sag. If this behavior lasts between half cycle and 1 minute is called sag. If it lasts longer than 1 minute is called undervoltage. Now let's imagine that one or more of the phases of our voltage drops below the 10% of the nominal voltage. This is called an interruption. Its duration is between half cycle and 1 minute. Interruption is the power quality problem with the most perceivable effect on facilities. It generally affects the industrial sector, particularly the continuous process industry. Unbalance. Voltage unbalance or imbalance occurs when the three-phase voltages in a power system deviate from a balanced state. This means the voltage magnitudes or phase angles between the three phases are not equal. In a balanced system, the voltage magnitudes are equal and the phase angles are separated by 120 degrees. Voltages are rarely exactly balanced between phases. However, when voltage unbalance becomes excessive, it can create problems for polyphase motors and other loads. Moreover, adjustable speed drives can be even more sensitive than standard motors. Voltage unbalance is primarily due to unequal loads on distribution lines or within a facility. Frequency variation. Power frequency variation is the deviation of the power system fundamental frequency from its specified nominal value, for example 50 or 60 Hz. Frequency variation may be caused by erratic operation of emergency generators or unstable frequency power sources. It is extremely rare in stable utility power systems, especially systems interconnected via a power grid. Where sites have dedicated standby generators or poor power infrastructure, frequency variation is more common, particularly if the generator is heavily loaded. Transients. Transients are very short power quality disturbances, from less than 50 nanoseconds to as long as 50 milliseconds, characterized with very high magnitudes of current and voltage, reaching thousands of volts and amps even in low voltage systems. Transients are caused mainly by lightning strikes or switching activities like transformers tap changing or capacitor bank switching. Transients are potentially the most damaging type of power disturbance. Damages due to such power quality problems are uncommon as compared to voltage sags and interruptions, but much more destructive. Transients may cause malfunction and damage of electrical and electronic equipment, overheating of motors and lighting failure. Finally, we have the unclassified disturbances. Unclassified disturbances refer to electrical events or anomalies that do not fit neatly into standard categories of power quality issues. These disturbances may be irregular, rare, or complex, making them difficult to classify using traditional definitions. These are events that do not match the waveform patterns of known disturbances. May be combinations of multiple types, for example, a sag with high-frequency noise. Could be caused by non-standard equipment behavior, cyber-physical interactions, or emerging technologies like inverters or EV chargers. Might be intermittent, non-repetitive, or localized. In the next video, we'll guide you step by step through how to navigate a power quality incident. You'll learn how to explore the incident's details and structure, filter incidents by date for targeted analysis, open and interpret detailed event data, download incident information as a CSV file, review associated alarms and events, understand the tolerance chart and what it reveals. Use the timeline tool to track incident progression. Stay tuned, and thanks for watching.